soon. I'm just waiting a couple more minutes. So this lesson we're gonna be focusing on arrays. Although we did talk about it a bit before, we thought it'd be better if we go a bit more in depth because it's gonna be pretty useful, especially in like the lower levels of USACO in the future. Um, so start off, first we have like our new meeting schedule. So we have a meeting today. Today's the 18th. Next week is Thanksgiving break, which we don't have a meeting on because Thanksgiving break. And then we have 3 meetings in a row before winter break. So basically, after December 23rd, the next time we'll see you guys is probably going to be in the new year. And basically, after this meeting, we're just going to be slowly focusing more on various USACO concepts and going more towards that direction. Also, for the sake of like our lessons from now on, we're going to be probably teaching more in Java, just because we found it like it takes a lot of time for us to like teach in Java and Python because that's like two different languages and like so it's like half the time we can teach. So that's why we're gonna just like our examples and everything are probably all gonna be more in Java. Although you can still do everything in Python, and if you are more comfortable in Python, that's totally fine. But if you guys like prefer Python a bit more and only know a bit of Java, we have also created some cheat sheets. So if you navigate to our website, which I'll send the link in the chat. But basically, we've started creating some cheat sheets. So if you go to posts and you see we have some posts here. So the first one, this is a Java cheat sheet. It's pretty in depth, although it's not in depth at the same time, but it covers a lot of different stuff. And it's pretty good for like a starter, especially like if you're a bit shaky on your Java concepts. Um, but we're going to be continuously updating this and it's going to be pretty useful because like, for example, we're going to be talking about arrays today, which we already have on the cheat sheet. And then the Python cheat sheet, it's not as updated as the Java one because we decided to focus on that one first because most people know Python already. But we're also going to be updating this regularly too, so it can hopefully have the same content information as the Java cheat sheet. So those are pretty useful, and you guys can use those when you're listening to like lessons or you're working on like problems. But now I think we're gonna just start coding. So as I said, we're gonna be doing this in Java. So if you have like your editor open, or if you don't, that's also fine. You can just follow along. Both should be fine. But basically, we're gonna just start off like just the basics of arrays again. We're just gonna skim them through. But first thing that's important is right in Java we need to create our main method. And if you guys forgot what this was, just basically just remember we're gonna need this every single time we create a Java file. And then now to create a 1D array, there are many different ways we can do that, but we're gonna create a pre-built array with some pre-built numbers in there. So int, so it's an integer array. We're gonna call it arr, just array. And then we're gonna have some numbers. Uh, So these are just random numbers. There's no like real purpose behind them. Um, but basically, this line right here is going to create an array, an integer array that has these numbers here. And so some things we didn't cover too much last time were like finding the maximum value or like the minimum value of an array. So obviously we're humans, right? So we can just take a look at this and we know that the maximum value is 8 and then the minimum value is 1. But for a computer to do that, we have to loop through the array and check if each value is greater than the previous value or if each value is greater than the temporary maximum value. So to do that, we're going to create a variable that's going to be called max. And we actually want to set this to the lowest number possible because we want to check if each number is greater than that number, right? Greater than max. So to set it to the lowest number possible, we'll have it to integer dot min value. This should be capitalized. Basically, um, integer.min value is like the lowest number possible that an integer can be. It's like 8 digits or something. And we're gonna set it to, we wanted to set it to the lowest value because we want to compare if the array element is higher than that number. And then we're gonna do the same thing for min, except we're gonna set it to integer.max value. And if you guys are confused why it's like min value, max value, you guys can just tell me in the chat. And then lastly, if we want to calculate the sum of the arrays, like 1 plus 3 plus 5 plus 6, blah, 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 we're just going to create a variable called sum and set it to 0. And so now to loop through an array, hopefully you guys remember how a for loop works. So we're going to do for int I is equal to 0, I is less than r dot length, then I plus plus. And this is just like the basic syntax formatting to loop through your array. And then now we're going to have some if statements to check if it's max or min. So if array of element I is greater than the max value, right? So if whatever element is greater than what is stored in max, then we're gonna store that element as max. So it might be a bit confusing, but it's actually pretty straightforward. And we're gonna do the same thing for min, except it's gonna be less than, right? So if the element is, or the integer is less than whatever minimum is, then we're just going to set that equal to. And then lastly, for sum, we're just going to, sum, we're just going to use a compound addition assignment. So sum will be plus equal to array of I. So once again, what this does, it checks if the current element is greater than the max value. If it is, then it sets that to the max. And then same thing for the minimum, except opposite. Then it adds each element to sum. So sum starts off as 0, it adds to 1, so now sum is 1. Then a plus equals 3, so then it equals 4, and so on. And check it works, we can just print out each of these variables really quickly. So print max. Print minimum, and then print sum. So hopefully this works. So you see we get 8, 1, and 25, which is correct because 8 is the max, 1 is the minimum. And I think if you add these, you should get 25. That should probably be true. And so that's basically just like a kind of quick crash course of 1D arrays in Java. And now this is like a newer concept that you guys might not have heard of yet, but these are array lists. So an array list is basically, it's a list, it's like an array, except the main difference is it doesn't have a set limit. So as you know, with Java arrays, you can't like add elements or remove elements because the size of your array is like permanent. You can't like modify the size. However, with array lists, the size is not permanent and you can add elements, remove elements, and basically do that. So that's pretty useful. So the format to create a new array list is going to look something like this. Note that I put string in here. You can put anything you want. You can put integer, boolean, whatever data type. And the reason why this is in red is because we actually need to import the array list class. So import statements basically import like different Java classes and like utilities. But if you don't understand that, it's fine. Just something I like to do is just to import java.util.asterisk. Asterisk stands for like everything. So it imports like everything under the util class, which includes arrays. So now you'll see the red lines have gone away. And then to add elements to your array list, you can do names.add, right? Names is the what we call the array list. And so let's add a name of Bob. And then let's add one more name and we'll add Alice. And so now to like print out each element of an array or like to grab elements from the array, we're going to do names.get. So system.out.println and then names.get. And in here, it's going to be the index value. So index value, right? So this also starts from 0. So this is index 0, index 1. So if we do get 0, it's going to print out Bob. So if we run our program again, okay, why didn't that work? Oops. All right, give me a second. All right, so you see it prints out Bob because that's index 0. And if we change this to 1, it should print out Alice because that's the first index, the first element in our list of our array list called names. And then we can also remove elements. So to remove, we're just going to do names.remove. And then we're going to put in the index value. So let's say we want to remove Bob. So we'll put names.remove 0. That's going to remove Bob. And then if we print out whatever's at the 0 index value, so names.get 0, we should get Alice again because Alice becomes the new, Alice takes Bob's place because we removed Bob from the array list. If that didn't make sense, you guys can let me know. I can slow down. But basically, that's like how to add and remove. And then quickly, the last two things we're going to talk about is index of. So index of is very useful because, like, for example, let's say you know for a fact that Alice is in our array list, and we want to grab the index of Alice. So we're going to do system.out.println, right? So, and then instead of names.get or names.add, we're going to do names.indexOf and names.index of, and then we're going to put the value. So this time, instead of putting a number, we're going to put the value. So we're going to put Alice. And this should output 0 because it tells us the value, the element which contains Alice should be the index 0. And that's true, so it outputs 0. And then last thing is names.size. So names.size is very similar to like array.length. It's just outputs the size of our array. So if we did this correctly, the size should be 1 because Bob has been removed and the only thing left is just Alice. And because there's only one element, that means the size is just 1. So if we run arrays.java, the size is 1. And that's basically what I really have for array lists. If you want to loop through an array list, it's like the same exact formatting as this, except instead of r.length, we would put names.size, right? Which is the length or the size of your array list. And that's basically array list. So I think Zenka is going to start talking now.
Okay, so let's talk about sorting algorithms. So an algorithm is like what you use to do something efficiently, right? And then sorting algorithms are what you use to sort an array efficiently. So it's basically trying to put them in order, and usually they're from like the least to the smallest to largest, right? So let's start with one of the more basic sorting algorithms called bubble sort. So the idea is simple. You try to you start from the beginning of the algorithms and you check if the next element is less than the current element, and if it is, then you move it back. But if it's not, then you focus on the next element and check if the next element is less than the current element. And if it is, you swap. So let's see it in action. So we sort, go, pause. Okay. So we start with 3 and 44, and we see that 3 is less than 44. So we should keep going, go to the next comparison. We focus on 40. We set the current element to 44, and we see if the next element is less than 44. And if it is, we swap them. And we do the next comparison. We're still focusing on 44 because it's the largest number that we've currently seen so far. And we see that 5 is less than 44. We swap them, and we just keep going. And so we'll change focus whenever we see a larger element. So in this case, 44 is less than 47, so we will change our focus to 47. And we keep going. And let's just continue. See, so as you can see, the bubble sort algorithm, it basically brings the the largest value you can find to the right. So after a series of iterations, you'll have the largest, and then the second largest, the third largest, and all the way to the smallest, all sorted up in order. So the reason why it's called bubble sort, because like in every iteration, you're trying to like the largest element bubbles up, right? So yeah. So yeah, now the list is sorted. So next up we have selection sort. So basically you start from the beginning of the list and you try to just wait a second. So yeah, you're basically trying to look for the smallest element, and then you move that smallest element to the beginning of the list. Okay, let me show it to make more sense. So you found this current smallest element is 2. So you move that to the beginning. You'll try to look for the next smallest element, and you move that after 2, and so on and so forth. So after the right side gets depleted, you'll have a list on the left that is sorted from smallest to largest. So we don't have to go through all of that. We can just skip. So yeah, so that's how selection sort works. And okay, for insertion sort, let me start sorting. So for insertion sort, you're basically trying to you'll have a left hand side and the right hand side similar to like the selection sort. On the left hand side, you have the sorted elements. So initially you won't have any on the left hand side, and and on the right hand side you have a list of like unsorted elements, like meaning that they're not in order. So in the beginning you have 3. So since the sorted elements doesn't contain anything, you can just put it in there, and now 3 is sorted. And next you keep going and you go for the next element 44, and you'll try to insert that into the left hand side, into the sorted array. So you see that 44 is larger than 3, so you put it after 3. And same thing, you'll try to compare this element to each of the previous elements, and you try to insert it into the right place. So whenever you see that the current element is larger than the left hand side, then you'll insert it after that element. So 5 is less than 38, but it's larger than 3, so put it here, and so on and so forth. We do the same thing until we have like depleted the right hand side, and the left hand side will be your sorted array. So we can fast forward. Yep, that's basically how insertion sort works. So now we have the merge sort. So a merge sort is a bit more complicated, but it's also a lot more efficient. Okay, let me try to. So a merge sort is what we would call a divide and conquer algorithm. So divide and conquer is a strategy that I use in algorithms to tackle big problems that you can't solve immediately by like dividing them into smaller problems and recursively. So you divide these subproblems and you divide them again into smaller subproblems, and so on and so forth, until you cannot divide them anymore. So when we have these smallest subproblems, you'll find them pretty easy to solve. And after you solve these solved problems, you try to combine the solutions to these subproblems into a bigger subproblems, and And after you've combined like everything, you'll get the actual solution to the original problem. So that's a like overview of how like divide and conquer algorithms work. So for merge sort, the divide process is dividing process is that you try to divide the original unsorted array into smaller into halves. So step one, you have the original array. Step two, you have the left hand side. So you try to the algorithm basically it tries to sort the left hand side of the array. So and then it sorts the right hand side of the array, and then merge these two halves together, and does so recursively. So as you can see, the sort function actually calls itself. So so whenever it's trying to sort something, it'll try to sort the left boundary up to the middle, and then it will sort the middle boundary to the right. So that's basically what is happening here. Okay. And after you've sorted the left hand side and the right hand side, you can combine them by calling the merge function, which is like right here. Okay, so let's just walk through this diagram. So okay, before that, I think it's better if I explain how you can actually use the sort function. So so basically, you create an array, and you call the sort function with this array, and then so the sort algorithm, not only does it require the unsorted array, it also requires a left-hand boundary and a right-hand boundary. But since we're sorting the whole array, we can just call the first element, which is index 0, and then the last element, which is length, the size of the array -1. So yeah, and yeah, so all right, let's get into the diagram. So in the first step, when you call sort array from 0 to array length -1, you will go into this sort function, right? And it'll first check if left hand side is less than right hand side, because if it's not, that means it only has one element in this subarray, and that means it's like it doesn't need to divide anymore, so it will return. So, but if it's less than the right hand side boundary, that means there are some elements in this array that it can still like divide. So you'll proceed to find the middle point of this array, and so in this case it's 3, and it'll try to sort the left hand side, so from 38 to 3. So it will do that first. So this is step 2. It'll sort from 38 to 3, and it'll go into the same sort function, but this time with a different boundary. So instead of from 0 to length -1, it'll sort the left hand side boundary to the middle point. So that's what we have here. And yeah, so from step 2, you'll go on to step 3. That's where it calls sort on 38 and 27, and then in this at this layer, it'll try to call sort array from 38 to 38, and this is where left hand side is not less than the right hand side, so it will just return. And after the sorting of 38 is done, you'll proceed to sort the right hand side, which is 27. And so after that it's done, and I mean after that's done, it will like combine the solution. So right now we have 38 and 27, and we're trying to combine them. And so the way so at this layer it's pretty easy to combine, since you can just put the smallest element first and the largest next. But when you have a pair of 2 element arrays, it's a tiny bit more like complicated than that. You can so in the merge function is where you try to merge the subproblems into a bigger subproblem. So as you can see, the L and the R arrays are basically the left-hand side and the right-hand side, and they're already sorted. And since we don't have to care about the exact implementation, just know that the L and the R are like they are the subproblems, the left-hand and the right-hand side subproblems. So the way we combine them is that we iterate through like both arrays, both subproblems simultaneously. So we'll have 2 counters for each array, and the counters represents what element we're on like currently for each of the arrays. And so here we have the main loop, and the loop will only so the loop will repeat as long as we still have elements in both arrays. So when one element runs out of array, when one array runs out of elements to sort, then we'll just break out of this loop, and then we'll copy the rest of what's left into the new array. So okay, so back to the main loop. So inside this loop, we'll check if the current element no wait, okay, let me restart. Okay, so in the main loop, we'll check if the we won't check, but we will compare the current elements for both arrays. So we see that 3 is less than 27, so we copy it into the sorted into the resultant array. So and then we increase the counter j by 1, so now it will point to 43, and we compare the current elements, which is 27 and 43, and we see that 27 is less than 43. We put it here, and we'll do the same thing. And we'll increase I by 1 to point to 38. We'll compare the current element. 38 is less than 43. We'll put it here, and then we'll break out of this loop and copy whatever is left, which is 43, into the final result array. And now we're done sorting this subproblem. So yeah, and then okay, so at the final step, when we're trying to combine the left-hand side and the right-hand side, it's a similar process. You're still comparing the current elements and trying to decide which one to insert into the final array. So in this case, I equals 0, j equals 0. So okay, 3 is less than 9. We'll put it here. I plus plus, so I equals 1, and then j equals 0. So 9 is less than 27, so you copy 9 into the final array, and then increment j. So j equals 1, and then 10 is less than 27. 10 goes here, and 27 is less than 82. 27 goes here, and 38 is less than 82. 38 goes here, and 43 is less than 82, so 43 goes here, and then the main loop ends because the left-hand side runs out of elements. And we'll continue with one of the while loops. So the while loops will copy whichever array that still has elements in it into the final array. So in this case, we're left with 82, and we know that it's sorted because the subproblem is like it's already been solved. Like this subproblem is already sorted, so we'll like whatever elements in there must be sorted, so we can just copy it into the final array, and now we're done sorting. So you might be like confused why I didn't explain the right half, but I mean it's basically the same thing as the left half. You're doing the same thing. You're trying to divide stuff into like one element subarrays and try to combine them. And yeah, it's the same thing. But also you might have noticed like the numbers here, and they represent the flow of the program. So it go from 1 to 2 to the 3. So it always starts from the left hand side because in the sort function you always call sort on the left hand side, the left half of the subproblem first. So you can imagine you start from the top, you call sort on the left hand side. So here you are, and then call sort again, and here you are, and call sort again, 38. And then yeah, when this sort function finishes, though, you'll return up, and then you'll do the right hand side. Return up, and you'll do the right hand side. And when this whole thing is done, you'll return up, and then you'll do the right hand side sorting. And so after both of these after both of those sort calls are done on the top level, you can proceed to combine them, to combine the solutions in the final step. So yeah, I think we don't have time to cover merge sort. I mean, we don't have time to cover a quick sort. So, but you can always check out the this visualalgo.net or visualalgo.net. I'm not sure if that's how you pronounce it, but yeah. And just check each of these visualizations out, and they're pretty cool. Yeah, I think I'm done. Eric, you can continue.
Yeah, so unfortunately, we kind of ran out of time. We still have some more stuff to teach, but basically, really quickly, I'm going to run through sorting a simple array in Java. So I actually didn't mention this yet, but to sort an array in Java, it's going to be arrays dot sort, and then inside the parentheses you want to put the array name. So we're going to sort R or ARR, whatever. So we just put that in there, and then that basically just sorts your array. And then now to check that our array is sorted, we can print out each element of our array inside this for loop. So now instead of seeing 1, 3, 5, 6, 2, 8, it should probably be like 1, 2, 3, 5, 6, 8 because it's sorted. And then so if we go up, we'll see it's 1, 2, 3, 5, 6, 8. And so it's a sorted array. And that's basically how it works.
Oh, by the way, the arrays.sort uses either like quick sort, merge sort, or like one of the algorithms, the efficient algorithms we mentioned. So yeah.
Yeah. You guys can read more about it on like Geeks for Geeks. But basically, we were going to go over some practice problems. So I'm really quickly going to navigate to HackerRank and just show the practice problems really quickly. All right, so the last two right here, 7 and 7 missing number and multiple missing numbers. So you guys should try this one first. This one's actually pretty interesting. Basically, you're given an integer array of numbers from 1 to n, blah, blah, blah. And then there's basically one number that's missing, and you need to find that number. So you can just check out the sample input, right? So 5. So array from 1 to 5 will have 1, 2, 3, 4, 5. However, your input only gives you 1, 2, 4, and 5. And so your program needs to be able to output 3. And there are like two like good ways to do this program. One of them involves like sorting the array and then comparing each element through a for loop. And the other method is a bit more mathematical, which is also pretty useful during the use cycle. Sometimes like you have to do everything. Sometimes doing some math will save you some time. But basically the second way would be if you guys know, right, from like algebra or whatever, the formula of like a sequence of numbers is n times n plus 1 divided by 2. And then basically, all right, so basically n times n plus 1 divided by 2 gives you the sum of numbers like let's say 1 to 5, assuming 5 is n. And then you can use that to subtract each value here. And it's a bit too confusing to explain. I'm just going to show my code for it really quickly. So basically, int n equals in the next int, right? So we're grabbing the value of n, And then to find the sum of 1 through n, we're going to do n times n plus 1 divided by 2. It's a formula, you guys can Google it. And then we're going to loop through the array, except make sure when you're looping through, you're going to only loop through n minus 1 because there are only 4 elements, not 5, even though n is equal to 5. And then you want to subtract the array element from your sum. So just for example, really quickly, if n was 5, if we were using this number, right, with 5 and 1, 2, 4, 5, so obviously 5 times 5 plus 1, which is 6, is 30, divided by 2 would equal to 15. So 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. And then we're going to loop through each of these digits, right? 1, so 4 times in total, we're going to loop through. And then we're going to subtract 1 from 15, which gives us 14. We're going to subtract 2 from 14, which gives us 12. Then 4 from 12, which is 8, and 5 from 8, which is 3, and your answer is 3. And then multiple missing numbers, multiple missing numbers is the same problem, except there are multiple numbers missing. So let's say it's 5 and it's 1 through 5, you have to output 2 and 4. This is going to be a bit more challenging, and we'll probably like show explanations after the meeting, probably when we see you guys again, or we'll post it on our GitHub after today's lesson. But it's like past 1:10, so if you guys need to leave, you guys can. We were also going to teach 2D arrays. So if anyone's like really interested in learning like what a 2D array is, you guys can stay and I can quickly teach that in like 5 minutes. Otherwise, we'll see you guys in 2 weeks after Thanksgiving break. Also, like if you really want to learn 2D arrays, can you like tell me in the chat and I can like, so I know. Otherwise, you're going to end the meeting soon. Okay, so I'm just gonna explain 2D arrays pretty quickly. If you guys need to go, you guys can go, feel free, but this will be pretty quick. So I already created this program. This is like a file earlier, but basically a 2D array, you guys have to think about it as like a table or like a spreadsheet, like a Google Sheets, Excel spreadsheet. So the formula, or not the formula, sorry, the syntax for a 2D array is very similar, except instead of one pair of brackets, you want to have 2 pairs of brackets. You want to have 2 sets of brackets or whatever. So as you can see here, we have 2 brackets and then 2 brackets here. And then normally you would just put the length of like your array, right? So normally in a regular array, it'd be like int BRR equals new int, and then this would be your length. So right, this would create an empty array of length 5. And here the 4 and 2, it outputs rows by columns. So we have 4 rows by 2 columns. And let's say if we were to change this to 5 and if we were to change this to 1, it would be 5 rows and 1 column. So like this would be disappear. So that would be your 2D array. But this is actually pretty useless because this is actually still 1D array. So normally this number here would probably be greater than 1. To loop through a 2D array, you're going to have a nested for loop or 2 sets of for loops. So the first for loop will iterate through the rows, and the second for loop will iterate through the columns. Let me just go back really quickly, change it to 4 and 2. So r.length, right? R.length gives you the length of the row, which would be 4. And then r of I.length is equal to the number of columns, which is going to be 2. And then normally when we want to print it out, you would just do the same thing as normal, except an extra pair of brackets. So r of I and j. So I'm just going to run the code. Where am I? Okay, so I'm running the code right now. Basically, as you can see, it outputs 0, 0, 0, 0 in a 4x2 table. And we output a space here because this space basically like gives you a space between the next element, like just for readability. And then this print line just creates a new line, once again, just for readability. And then I created like a quick example of a 2D array. So this is like a tic-tac-toe game. So as you can see, it outputs a bunch of dashes. This is a 2D array right here, which we call tic-tac-toe. And then like it's your turn, player 1. So this is a bit complicated. I don't know why I made it, but basically like you can set different values, blah blah blah, and it's pretty cool. So those are like the uses of 2D arrays. You're gonna see 2D arrays a lot when it comes to programming, especially much later, like in USAC or whatever. Basically, the format is very similar. You can think about it as an array of arrays, but if that's too confusing, just think about it as like a table that's rows by columns, and that's about it. So if you guys have any questions, you can ask them. Otherwise, I think we're gonna end the meeting soon. Chanjark and Patrick, do you guys have any questions? Okay, well, if you, oh, nice. All right, I'm gonna end the meeting. Just a quick meeting Discord right now.